Hello and welcome to naming and writing formulas of ionic compounds. Be prepared that these notes will be a little bit longer than the previous videos, but that is because this video is going to sustain us for 2 days. So you will not need to watch the entirety of this video, just the parts of the video that are appropriate. So in chemistry, we use a lot of symbols and formulas and equations because in chemistry we are typically trying to describe chemical reactions, how different types of matter interact with other types of matter and what happens. And to write it out in long form with words and sentences and paragraphs was just confusing. So in chemistry, we have to understand how these symbols relate to each other and what that actually communicates. So that's what we're going to be looking at in these slides, namely looking at formulas of compounds, right? We think of table salt, sodium chloride. That is made up of particular elements. So how do we write the formula that tells us what elements we have and how many we have in there? As you can see here on the bottom, each element starts with a capital letter. This is an important part. If you look on the periodic table, you will see that a lot of the elements have 2 letters in their symbol. So it's important to denote capital versus lowercase, because when I look at a formula, the number of capital letters tells me how many different elements I have. One word of caution, especially doing these on the computer, that sometimes a lowercase l and a capital I look the same. So I will do my best to kind of communicate when that happens to denote if it means a capital I or lowercase l. But if you're unsure, make sure you always ask. We are going to be focusing only on ionic bonding in these sets of notes. An ionic bond is a bond between a positive ion and a negative ion. It is one of the telltale, there you go, signs of an ionic bond is that it's between a metal and a nonmetal, and it involves a transfer of electrons. If you look at the picture here, you see this electron is physically moving from one atom to the other. That's what makes it an ionic bond. So here it's just mindful. Again, we have this stair-step line. It's important that you know that the metals are over here on the left and the non-metals are over here on the right. Because on the test, I'm not going to tell you that it's ionic. So one of the things that you have to know is be able to look at a formula, identify that there's a metal and a nonmetal, and therefore it's ionic. Okay. A couple other definitions to be mindful of. One is a polyatomic ion. This is a group of atoms that together have a charge. And multivalent metals, right? Multi meaning multiple, valent meaning charges. So this is a metal that can have multiple charges. Okay. A lot of these you're going to find on that pink sheet. The common ion chart is what we're primarily going to be using. Every compound that I might give you, I'm going to be using ions from this chart. It's a list of just single atoms like aluminum or barium or sodium, or polyatomics like bromate and oxalate and chromate or sulfate. You'll notice on the left-hand column there are some that are shaded, like chromium with a Roman numeral 2 and chromium with a Roman numeral 3. That's an example of a multivalent metal. It's a metal, chromium, but it has multiple charges. It can be +2 or it can be +3, which is why we have a difference in what they are named. If you don't have these hot sheets or you lost them, under course info, There's a folder titled Hot Sheets, Periodic Table, Mole Map, Chem Help Sheet. This is where you will find all that stuff. So if you need a periodic table, if you need the common ion chart, it's all in here. So one of the things that you're going to have to be able to do that's going to be important is, given a formula, you need to identify the polyatomic ions. And the reason this is going to be important, especially when we get to naming, is if there is a polyatomic ion present, it changes how we name the compound. So if you can't identify the polyatomic ion, then you're probably going to name it incorrectly, which would get points off on the test. So if I were you, I would pause the video here, maybe write these examples down in your notebook, and then just circle the polyatomic. So have your ion sheet out in front of you, and this is really just a game of matching. So go ahead and pause the video and give it a shot right now. So hopefully you paused the video, and let's reveal the answers. So for this first one, we have NO3. That is also called nitrate. Next, we have NH4. NH4 is called ammonium. Next, this one's a little easy because it's in parentheses. We have the OH. If you look on the pink sheet, OH is called hydroxide. In this next one, we actually have two polyatomic ions, the NH4 and the PO4, which is ammonium and phosphate. And the last one is CO3, which is carbonate. Okay? Let's talk about writing formulas. So the setup is somewhat simple. When we write a formula, is we first write the symbol and the charge. Both of these can be found on the pink sheet. And we write the symbol and charge of the negative ion, the anion. And then we can simply add positive and negative ions until we have a neutral compound, or the crisscross method, which is a little bit of a shortcut kind of method. Here, which is highlighted in yellow, this is an important part. I believe this is a question on the test, is we want to use subscripts to show how many of each type of ion there is to balance the charge. And that is ultimately what we're doing. We're trying to make the amount of positive charge cancel the amount of negative charge. And we're going to look at a few examples. And the last thing, again, we'll see examples of this. When you have a polyatomic ion that you have to put a subscript by, put it in parentheses. Again, let's look at some examples. So how to determine the charge? Again, use your pink sheet, your common ion sheet. That's what you're going to want to use. You could use your periodic table, but don't. Use your pink sheet for ionic compounds. So let's look at this first one, calcium bromide. So the first thing I want to do is find calcium on the pink sheet, which is Ca plus 2. That's my cation. It's my positive ion. And then I want to find bromide on the other side, on the pink sheet, which is Br minus 1. It's an anion. If I were just to add them together, focusing on the charges, plus 2 plus negative 1, that does not equal 0. My purpose here is to make the charges equal 0. So the question is, what do I have to do to make the charges equal 0? And if you said, well, you need to add another bromine to it so that it's plus 2 minus 1 minus 1, that equals 0. Once it equals 0, now I know how many of each ion it takes to balance out the charge. So it takes 1 calcium and 2 bromines. So I'm going to use a subscript of 2 to show that I need 2 bromines. And so I end up with this as a formula. Notice the subscript is written below. That's what sub means. Sub means below, like submarine or subway. It all means below the surface. So in this case, it's a subscript below writing script, so it's going towards the bottom. It seems like a trivial point, but position matters. Capital letters, case letters, lowercase letters, all of those things matter. So it's important that it's a subscript. Now let's do the exact same example, but using the crisscross method. So our same process, we find calcium, which is +2. We find bromine, which is -1. And what we're doing is we are crisscrossing the numbers. So I'm taking the 2, and if you follow the arrow, notice where it ends up. It ends up right here in the bottom right-hand corner of BR, and that's what I end up with my formula. You might be thinking, well, what about the 1? Well, the 1 comes down here, it crisscrosses, the lines crisscross, and I end up with 1 calcium. But I don't write 1 in the formula. We never write the number 1 when we're writing formulas. So we just get CaBr. Let's look at another example. Copper to nitrate. Our first steps are still the same. Look on the pink sheet, find copper with a Roman numeral 2. And that's Cu plus 2. Find nitrate on the pink sheet. Nitrate is NO3 with a -1 charge. Now, like our previous example, if I add the charges together, it doesn't equal 0. So what do? Well, I need another nitrate, just like before. But nitrate is a polyatomic ion. So how do I write that I have 2 of those? Well, this is where parentheses comes into play. I can't change NO3 to NO2 because NO2 is not nitrate. Look on the pink sheet. NO2 is nitrite. I can't just write NO32 because someone might interpret that as NO32, and I don't have 32 oxygens. So this is why with polyatomic ions, it is important that you use parentheses. Anytime you have to write a subscript with a polyatomic ion, you must use parentheses. Let's look at this with the crisscross method. Notice that our first steps, no matter what method we use, is the same. Look at the pink sheet, find the charges. And when we crisscross, notice the 2 comes all the way over here to the 3. That's why I have the 2 here. The 1 crisscrosses, and that's how I only have 1 copper. Again, I do not write the number 1. I never write 1 in the formula. Third example, calcium carbonate. Pause the video and try doing this one on your own and see what you come up with. Hopefully you did that. It's good practice to do that. Let's go over how we arrive at the answers. I'm going to skip through our first steps. Again, it's using the pink sheet. Just find calcium, find carbonate. At this point in time, you might notice that the first part of the name is always the positive thing, right? The cation always comes first. Positive always goes first. You always give people good news before you give them bad news. You always build people up so that you can tear them down later, right? That's just kind of how it works. For example, you come home, hey, mom and dad, the good news is the car is okay. The bad news is the cat's dead, right? Now, that analogy doesn't quite work because both of those are actually good news, but I think you get the point. Positive always goes first. Now, this is an example where when I add my charges together, +2, -2, it already equals 0. So I'm already at my end point, my goal. I'm trying to get the charges equal 0. So how many of each are needed to get that? Well, it's 1 calcium and 1 carbonate. I don't need parentheses. I don't need, anything else. This little thing, the subscript of 2, that shouldn't be there. Cross that out. This should go away. How do I do that? Don't read this. This is a typo. That shouldn't be there. Now, this is an example where if we use the crisscross method, it would be a problem. Because if I were to do the crisscross method, I might say, hey, this should go down here and this 2 should go down here, and it should be Ca2, CO3, 2. Well, remember, the crisscross method is just a shortcut. It's just a way to bypass what's happening. Chemically speaking, we're trying to make the charges equal 0. The crisscross method just normally works, but in some situations like this, because the charges already cancel out, you can't do the crisscross method. Okay? So here's just another example. Iron with a +3 charge, oxygen with a -2 charge. Again, that doesn't equal 0. So you just add ions until it equals 0. So it takes 2 irons, it takes 3 oxygens, and so we end up with the formula. If we look at this example with the crisscross method, you'll notice that where did this 3 go? This 3 right here. Oh, it went down to the oxygen. Go away. Where did this 2 of the oxygen go? Oh, it went down to the iron. I can't put my pointer here because that thing will pop up. Oh, there we go. So the crisscross method would, again, be another place you could do that. So let's practice. So here's some examples. Again, pause the video and try doing these on your own. Okay, hopefully you did that. Let's go over the answers. Okay. So hopefully you got those right. If you didn't, feel free to rewind and go back and watch any part that you didn't get. Let's try these. This is one that has some polyatomic ions in there. So again, pause the video and give this one a try. All right, hopefully we had a little bit better luck this time. So sodium nitrate, calcium chlorate, needs parentheses because you have 2 of them, potassium sulfite, and this one you probably missed, calcium hydroxide. Hydroxide is a polyatomic ion, and you have 2 of them. And so polyatomic ions require parentheses. And then last, let's try some examples where we are doing the multivalent metals. So again, pause the video and try these 4. Let's look at the answers. So not a lot changes with these because the Roman numeral tells you what the charge is, basically. And then when I crisscross, that's kind of how I end up with lead 4. Well, where does 4 come from? Because the lead was +4. And then this example right here is an example where the crisscross method, +2, oxygen is -2, those charges would have canceled out. Now let's go to naming ionic compounds. So to name ionic compounds, it's actually relatively simple. There's just 2 steps. Write the name of the first thing, write the name of the second thing. Ultimately, that's what it is. You're going to be using your pink sheet for this in order to do this. Now, there are a couple of caveats. Like I said, if we have a polyatomic ion, it does change a little bit our protocol of how we name it. And it's namely here in the end. We always end in IDE unless it's a polyatomic. If it's a polyatomic, we don't change the ending. Okay? And then the other caveat is if that first metal, like iron or copper, are one of those gray highlighted ones, you have to use a Roman numeral. We have to designate which one is which. So let's look at an example, right? So CaBr2. Look on your pink sheet. What's Ca? Ca is calcium. What's Br? Br is bromine. But we don't write bromine. We change the ending to IDE, so it becomes calcium bromide. Let's look at this. What's K? You look on your pink sheet. You find K. It's potassium. SO4. It's a polyatomic. I know it's a polyatomic because it has two capital letters. Remember how elements start with a capital letter? This is where it's coming in handy. So then I just look on the pink sheet and where's SO4? Sulfate. So what's the name? Potassium sulfate. NH4. Notice the parentheses. That makes it pretty easy to identify that it's a polyatomic ion. You find NH4 on the pink sheet, it's ammonium. S. What's S? S is sulfur, but I changed the ending, so sulfur becomes sulfide. So my name is ammonium sulfide. The last one, this is probably the hardest, is those multivalent metals. I know that it's iron. CO3, the parentheses, it's polyatomic. I look on the pink sheet, CO3 is carbonate. But how do I know which iron it is? Iron has multiple charges. Is it iron with a Roman numeral 2 or is it iron with a Roman numeral 3? And this is why it's one of the hardest ones that we can give. To do that, I need to figure out the charge of carbonate. I look on the pink sheet, carbonate has a -2 charge. I look at the formula. There are 3 of them. So I take the charge times the number of ions, which is -6. Well, I need the charges to equal 0. So that means that the iron, the 2 irons, have to equal +6. So what does iron have to be so that 2 of them result in +6? And you guessed it, 3. So that's how I know it's iron with a Roman numeral 3 carbonate, and it's not iron with a Roman numeral 2. This is one of the most missed on the test, is because people try to shortcut. They look at the 2 next to the iron and they think, oh, that's the Roman numeral. And you could not be more incorrect. The Roman numeral is the charge. Okay. So here's some 4 problems. Let's go through and practice these. So go ahead again, pause this, and try to write the name of these 4 compounds. Hopefully you did that. Here are the answers. Calcium fluoride, sodium phosphide, sodium fluoride, strontium bromide. Again, notice they are all ending in IDE. Let's try some with polyatomic ions. Notice all of the capital letters. That's how we know it's polyatomic. So pause the video and try doing these 4. Okay, let's look at the answers. And let's do one more set of examples, but this time with elements that are the multivalent, those shaded gray. So you got to figure out what is the charge of the metal. So go ahead, pause the video and try doing that. Okay, so for this first one, lead is +2. For the second one, lead is +4. So that's how I know which Roman numeral it is. These next ones are manganese. Notice how there's only one manganese and one oxygen. That means the charges cancel out. So I know that manganese is +2, which results in a Roman numeral of 2. And the last one is manganese 3 oxide. Okay. And that's the end of the notes. It's a long one. My voice is hoarse. So I'm going to stop talking.